Projections. What is a projection? A projection is a system used to transfer locations from Earth's surface to a flat map. This can result in distortion of the relative size, shape, direction, and distance between land masses. The Robinson projection. Devised by Arthur Robinson in 1963, this projection is neither equal area nor conformal, rather represents the compromise between the two. The advantages. Correct size and shape of most land masses and accurately shows the size of oceans and distance across land. Disadvantages. Distortion near poles, not equal area or conformal, replaced by the Winkel-Triple projection. The Mercator projection. Introduced in 1569 by Gregardus Mercator. Used for navigation because a straight line is a line of constant true bearing. Less practical for world maps because areas further from the equator are disproportionately large. The Peters projection. Introduced by James Gall and Arno Peters. It appears vertically stretched at the equator and horizontally stretched at the poles. It shows geographic relationships based on size better than the Mercator projection. The Fuller projection, also known as the Dymaxion map, patented by Buckminster Fuller in 1946. The Earth is displayed on the surface of an isohedron, which can be unfolded. Advantages: less distortion of relative size of areas and shape of areas. Disadvantages: not projected in a way we usually perceive direction. There's no up or down. It can be unfolded in many ways. The Transverse Mercator, by Johann Heinrich Lambert. It's an adaptation of the standard Mercator projection and is widely used in national and international mapping systems. It delivers high accuracy in zones less than a few degrees in east-west extent when paired with the suitable geodetic datum. It results from projecting a sphere onto a cylinder tangent to the central meridian. It portrays areas with a larger north-south than east-west extent. Distortion of scale, distance, direction, and area increases as distance from the central meridian increases. The Miller Cylindrical projection, by Osborne Maitland Miller. Has straight meridians and parallels that meet at right angles. Straight lines are not of constant azimuth. Shapes and areas are distorted. Directions are only true along the equator, and it avoids the scale exaggerations of the Mercator map. The Stereographic projection. The oldest record of this projection is from Ptolemy in 150 AD. This is commonly used over the poles, but can be used for small-scale maps of continents. It appears as if you were looking at Earth from space or at a globe. This projection preserves the shape of continents, and large distortions happen towards the edges of the map. Directions are dependable from the center, but the map is not equal area. Cotthill's butterfly map. All continents are uninterrupted and remain true to the shape of the globe. Cothill proved this by creating a rubber ball globe that could be flattened into a butterfly form and still return to its ball form. Thank you for watching.